Welcome back to our Video Electrical YouTube channel. Please give feedback to us for more number of electrical videos. Let us discuss concept of rotating magnetic field RMF in three-phase induction motor. Just you consider this is a three-phase induction motor. I'll be giving three-phase supply over here. Three-phase voltage. Okay. Due to voltage, current will flow through the coil IR, IY, IB. If suppose coil carries a current, what happens? It induces a flux, right? That flux rotates at a speed of Ns is equal to 120 F by P. See, 120 is the phase angle. All the conductors are placed 120 degree apart each other. I mean R conductor, Y conductor, B conductor. Produces flux also 120 degree apart each other. That is phi R, phi Y, phi B. This IR produces phi R and an IY produces phi Y and an IB produces phi B. Right? As you can see the diagram, three-phase supply we are giving into the stator field coil. What happens? Produces magnetic field is like this, sinusoidal, right? And rotor is the rotating part of the machine, right? Due to rotating magnetic field, this rotor start rotating. This phi R sinusoidally distributing, and then phi Y and then phi B. See, all the fluxes placed 120 degree apart each other. That is 120 phi R, phi Y, phi B, right? As you can see the diagram, how exactly flux will be distributed in the inside the three-phase induction motor. Okay, we'll discuss RMF in detail. So I'll begin three-phase supply to the stator. Okay, R, Y, B input. So here there is a stator R conductor, and then this one is a B conductor. This one is a Y conductor. Okay, so R dash, Y dash, B dash, right? So this R is connected over here, and then this Y is connected over here, and then B is connected here, right? So due to voltage, current will flow through the circuit. Due to voltage VR, VY, VB, so current will flow through the winding. What happens? Produces current is IR, IY, IB, right? So due to current flowing through the coil or winding, what happens? Produces flux phi R, phi Y, phi B, right? So all the conductors placed 120 degree. This is 120 degree, this one 120 degree, 120 degree, right? So 120 degree apart each other, right? So we can say phi R, phi Y, phi B. What about phi R from this equation? Phi R is a reference. Phi R is equal to phi m sin omega t, right? Maximum flux omega t. Because sine wave, right? Even though flux is also sine wave, like this. This one is phi R is a reference. This one is phi Y. This one is phi B. 120. This is 240. We can say plus 120 also possible. So what about phi Y? Phi Y, just to consider 120 clockwise direction. Phi m sin omega t minus 120, right? 180 degree. And what about phi b? Phi b is equal to phi m sin omega t plus 120 or minus 240. So here to here minus 240, here to here plus 120. So plus 120 I'll take. Okay. These all are rotating magnetic field in the stator. So how exactly it is rotating? As you can see the diagram here. How exactly flux is distributed like this? It will rotate at the speed of Ns equal to 120 F by P. So 120 is the phase angle, right? Supply we are giving voltage VR, VY, VB, all sinusoidal voltage because AC. Due to voltage, current will flow through the coil. I mean AC current. So what happens? Produces sinusoidal flux, that is phi R is equal to phi m sin omega t, phi Y is equal to phi m sin omega t minus 120, phi B is equal to phi m sin omega t plus 120. As you can see the diagram, if you give power supply over here, what happens? It produces rotating magnetic field at a speed of Ns is equal to 120 F by P. So that phi R conductor produces flux phi m sin omega t, already we derived. And what about phi Y? Phi Y is equal to phi m sin omega t minus 120. What about phi B? Phi B is equal to phi m sin omega t plus 120, right? So these are the flux in the induction motor, very important, right? So case 1, omega t is equal to 0 to find resultant flux. So phi r directly I can write 0. What about 5y? 5y is equal to 5m sin 0 minus 120. You will get minus root 3 by 2 5m, right? What about 5b? Similarly, 5m sin plus 120. You will get root 3 by 2 5m, right? So, based on these values, we'll draw a vector diagram. There is a R conductor produces flux phi R resultant, and this one is Y conductor produces flux phi Y, and then this one is phi B. R conductors 120 degree apart each other. Okay. See the conditions. Phi R is equal to 0. There is no phi R. Definitely it is 0. Right. I will be eliminating. Only phi Y will be there. Phi B will be there. So that phi Y is minus. So I'll take here minus phi Y. Right. This one is 60 degree. Okay. Here to here another 60, 120 total. So if you want resultant flux, just you take one resultant line phi R, this one, just you add here to here, you will get resultant flux in the three-phase induction motor. What about cosine rule? So phi R is equal to root of phi B square, this one, plus minus phi Y is there, minus phi Y square, minus 2 phi B phi Y cos how much total? 60. So what about phi B? Phi B is root 3 by 2 phi m square, right? And phi Y is also minus root 3 by 2 phi m square, minus root 3 by 2 phi m square, minus 2 phi B is root 3 by 2 phi m. What about phi Y? Phi Y is minus root 3 by 2 phi m. I'll take plus over here. So here root 3 by 2 phi m, and cos 60 is 1 by 2. These two get cancelled. You will get phi R is equal to 3 by 4 phi m square plus 3 by 4 phi m square, because minus square will be there, it will become plus. Okay, root 3 by 2 phi m into root 3 by 2 phi m. Definitely we will get 3 by 4 phi m square, right? So finally, phi resultant is equal to 3 times 3 by 4 phi m square. If you take root outside, so 1 3 get cancelled, and 2's and phi m square, this root get cancelled. You get finally phi R is equal to 3 by 2 phi m. So phi R is equal to 1.5 times maximum flux in the three-phase induction motor. Okay. Another one method, second method. So just you draw one perpendicular line. This one O, A, B, and this one C. So this is 30 degree. What about cos 30? Cos 30 is equal to adjacent by hypotenuse OC by OB. What about OC? Phi R divided by 2, right? Because total is phi R divided by 2. This is OC. And OB is phi Y, that is root 3 by 2 phi M. Okay. So what happens? 2 get cancelled. See here, cos 30 is root 3 by 2 is equal to OC is phi R divided by root 3 will be there, phi M. So what happens? It multiply over here. So finally you'll get phi R is equal to root 3 into root 3, 3 by 2 phi M. Right? This is another one method. Okay. You can consider any one method. See, this is how flux will be distributing over there. Similarly, I'll take case 2. Omega t is equal to 60 degree. Okay. So what about phi R? Phi R is equal to phi M sin 60. So we'll get root 3 by 2 phi M. And what about phi Y? Phi Y is equal to phi M sin 60 minus 120. Definitely you'll get minus root 3 by 2 phi M. Okay. What about phi B? Phi B is equal to phi M sin 60 plus 120. You will get 180. So phi M sin 180 is equal to 0. There is no phi B term. Okay. I will draw a vector diagram for this one. There is a phi R and then phi Y. This is phi B. See here, phi B is not there. I will be eliminating this one. Okay. So what about phi Y? Minus phi Y will be there, right? So here minus phi Y. So this is 60 degree. And this one is 120. Okay. See, if you want a resultant of this flux, just to draw one straight line, that is phi r resultant line. Just you add here to here. So if you want phi resultant, apply cosine rule. Root of phi y square minus will be there plus phi r square minus 2 phi r phi y cos 60. So finally phi r is equal to, just to substitute, root 3 by 2 phi m square plus root 3 by 2 phi m square, minus will be there, but here phi y minus will be there. I'll take plus over here. Minus into minus plus will get afterwards. 2 root 3 by 2 phi m, root 3 by 2 phi m, cos 60 is how much? 1 by 2. Finally, we will get phi r is equal to 3 by 2 phi m. Okay. Phi r is equal to 1.5 phi m. Next, omega t is equal to 120 degree. Just I'll substitute phi r is equal to phi m sin 120. We will get root 3 by 2 phi m. What about phi y? Phi y is equal to phi m sin 120 minus 120. You will get 0. Only you will get phi b. Phi b is equal to what? Phi m sin 120 plus 120. You will get 240. So 240 in the sense minus root 3 by 2 phi m. I'll draw a vector diagram for this one. This one is phi r, phi y, and then phi b. All are 120 degree apart each other. Okay. So here phi b is negative. So phi b is negative in the sense minus phi b this one. But phi y is 0. I'll eliminate this one. Okay. So resultant, if you want, just to take phi r this one. So this one is total 60 degree, right? This one is 30 degree. Okay. So if you want resultant, apply cosine rule. Phi r is equal to root of phi r square plus phi b square minus 2 phi r phi b, minus phi b will be there. So afterwards we'll take this one is plus cos 60. So what happens? Phi r is equal to, just to substitute, phi r is equal to root 3 by 2 phi m. Phi b is equal to minus root 3 by 2 phi m. Finally we'll get 3 by 2 phi m. 1.5 phi m. Okay. Omega t is equal to 180 degree. Right. Finally, so phi r is equal to phi m sin 180. What will get? 0. What about phi y? Phi y is equal to phi m sin 180 minus 120. We'll get root 3 by 2 phi m. What about phi b? Phi b is equal to phi m sin 180 plus 120. We'll get minus root 3 by 2 phi m. Okay. I'll draw a vector diagram for this one. There is a phi r and then phi b. This one is phi y. All the fluxes placed 120 degree apart each other. Right. So here phi y is root 3 by 2 phi m. Phi r is not there. Phi b is there. Minus phi b will be there. So this is minus phi b, opposite of this conductor. Okay. So phi r is 0. I'll just eliminate this one. So what happens? I'll be taking resultant here to here, here to here. This is phi r. Just to apply cosine rule, phi r is equal to root of phi, see here, phi y square plus minus phi b square minus 2 phi y phi b cos 60. Right. So just to substitute value, phi y square is root 3 by 2 phi m square minus phi b square will be there. See here, minus will be there. Square root, it becomes plus 3 by 2 phi m square minus will be there here, phi y phi b. So phi y is root 3 by 2 phi m, phi b is minus root 3 by 2 phi m. So definitely you will get plus 2 root 3 by 2 phi m and root 3 by 2 phi m cos 60 1 by 2. Finally you will get phi r is equal to, just you will get 3 into 3 by 4 phi m square. After taking root outside, 1.5 phi m resultant. All are equal. If it is omega t is equal to 0, 60, 120 and 180, we will get resultant flux 1.5 phi m. Okay. Any one method you can follow. This cosine rule are like this. Just you take one midpoint over here. This is C, this is O, A, B. This is 30 degree, right? So what about cos 30? Cos 30 is equal to OC by OB, right? What about OC? Total is 5R, so 5R by 2. What about OB? OB is, see here, OB is root 3 by 2. Root 3 by 2 5M. So root 3 by 2 5M, right? So 2 get cancelled. We will get 5R by root 3 5M. Finally, cos 30 is equal to root 3 by 2. You will get 5R divided by root 3 5M. So just to multiply here, you will get 5R is equal to 3 by 2 5M. So 1.5 5M. Any one method you can follow, okay? Final touch, how to remember RMF. Just you put omega t is equal to 0 degree, 60 degree, 120 degree or 180 degree, okay? But these equations were must for this derivation. Phi r is equal to phi m sin omega t. Phi y is equal to phi m sin omega t minus 120. Phi b is equal to phi m sin omega t plus 120. How we got these equations? From this, okay? This is phi r, this is phi y, this one is phi b. 120 degree apart each other, okay? If it is clockwise direction, for phi y we need minus 120. See, 120 will be there. If we phi b, if you want plus to 120 or minus 240, because phi r is the reference, okay? Just to put these values over here. Here in this we'll get any two of the values. Phi r is equal to root 3 by 2 phi m, and phi b is equal to minus root 3 by 2 phi m, and one value definitely becomes 0. For all the cases, we will get resultant flux 3 by 2 phi m. So 1.5 times of maximum flux in the 3-phase induction motor. That's all.